So 3.2 AB is arithmetic sequences. So I can determine if a representation is arithmetic or not. So we need to talk about what it means to be arithmetic. So let's get started here. An arithmetic sequence is an ordered list of numbers in which the difference between each pair of consecutive terms or numbers in the list is the same, which is called the common difference. In an arithmetic sequence, you are adding or subtracting by the same number each time. So if you are adding or subtracting by the same number each time, what does that remind you of? You're adding or subtracting by the same number each time, what does that remind you of? If you're adding or subtracting? But if I'm constantly adding 4, I'm not multiplying. You see what I'm saying? So what are we looking at here? Yeah. It's like the slope of a what? Line. So we're looking at things that are linear here. So we are looking at things that are linear in arithmetic sequences. So arithmetic sequences are linear. So that's what we'll compare it to, is linear things. So the next word in there is the common difference. So a common difference is much like your slope. It is whatever you're adding or subtracting by. Which should remind you of your slope. So that's what an arithmetic sequence is. Are you guys done with it in this one? The arithmetic sequence is a linear representation in a sense. The only difference is you're not going to draw a line in sequences. Sequences are specific points at 1, at 2, at 3, at 4, at 5. They are not lines drawn. They are just individual days, which makes more sense in some of the things we do than having them as lines. Like when we're talking about the number of people, does it really make sense to have a line connecting all the points? Because can you have partial people? No. So in some situations, it makes more sense to do arithmetic things. There's a few other differences, too, that you guys will notice. So arithmetic, you will not connect the lines on a graph. And the other big difference is that you start at 1 and not 0 like in a line. So those are just some other differences that you guys will notice over the next couple of days. So let's get started with some examples. Using the figure, complete the table, plot the points, and describe the pattern of the y values. So let's first talk about things here. When it says plot the points, arithmetic, if it's an arithmetic problem, do not connect the points. Also, you start at 1. Not at 0. So, arithmetic is a little bit different than linear. Linear, you would connect your points. Arithmetic, you do not. You start at 1 in an arithmetic, and in linear, you start at 0. So, those are some differences there. So number of stars and the number of sides in the star is what we're looking at. So n equals 1. N is what we use for the x-axis now. N is whatever term you are on. So that's the term number you are on. So instead of an x, we use an n, and then number of sides is still your output, so that's the number of sides there. So, Avery, how many sides are in that first, if you have 1 star? 10. So how many sides are there if you have 2 stars, Alex? Good. Morgan, how many sides will there be if there's 30 stars? 30. I meant 30 stars, I meant 3, but yes, I just gave you the answer while I was speaking. Olivia, how about 4? And Kaylin? Good. So we just plot the points. All we are doing is plotting the points. So at 1, we have 10 sides. 2, we have 20, 30, 40, and 50. We do not connect the points or anything there. It just looks like that, and we start at 1. So it's still like an ordered pair, though. So Madison, describe the pattern that you notice on this graph, or from the table even. It is positive. What else do you notice, Madison? It increases by 10, which is known as your common difference. So each term increases by 10. So your common difference is 10. So your common difference is like your slope. So when you see here the word common difference, which can be labeled with a D, it's like your slope. So the next one, let's start filling out that table there. So n is the term you are on and the number of circles that are in the image there. So Jessica, how many circles are there in image 1? How many circles are there in image 1?
Oh, 2. I'm calling Jessica, that's why I was like...
Jill, sorry. You know, your sister is not in my class anymore. Jenny, how about in number 2? 3. 1, 2, 3, count the circles again. Is it 3? No, you're right. No, you're right. You're 3. I was looking at the wrong... Why does mine... Oh, I'm looking at the wrong one. It's my fault, not yours. Jacqueline, 3. 4. Alexis, how many are there in 4?
5.
Good. And Albin, how many are there in 5? Okay. So you can plot your points. Remember, you start at 1, and with an arithmetic sequence, you never connect the points. So Iris, what pattern do you notice is happening here? Each term increases by 1, so our common difference is 1. Remember, common difference is the same thing as like a slope. So look over those first two examples and see if you have any questions for me. So this arithmetic sequence part we'll go through Monday of next week, and then we'll be reviewing for your test. Your test will be next Friday. So I will get you guys your review on Thursday to start working on, and I'll get the answer key up sometime next week for you guys to look on, but at least for you guys to start working on. Does that make sense? So I wanted to make sure that you guys realize that, so I think it's November 4th is that Friday, is your test, okay? So we'll review Tuesday and the block day of next week, and then we will take your test, okay? Let's look at the next one here. Decide whether the sequence is arithmetic or not. Explain using the common difference. So remember, common difference is like the slope. So common difference is like slope. And arithmetic means you either have to add or subtract. So Olivia, is that first one, number 5, example 5, arithmetic or not? Why? Arithmetic, because you have a common difference of -4. It's like you're saying you have a constant rate of change, right? Yes. That's fine. If you say D equals -4, that's fine. Yep. Kelly, how about number 6? Why not? Well, it's not subtracting or adding by the same amount, right?
Yeah.
It looks like it's dividing by 4 each time, actually. So is division arithmetic? No, we're going to learn about geometric sequences and exponentials in the next unit, and that's when you're multiplying or dividing. So it's not arithmetic because you divide by 4 which is not addition or subtraction. Okay, Mackenzie, that last one there. Why not?
Because you're not adding by the same number.
You're not adding by the same number. This is 4, 4, and then all of a sudden it is 6. So there's no common difference here. So it's not arithmetic. Also not geometric, which you guys will learn about. Because your common difference is not the same. Because you don't have a constant common difference. I think we only have one more slide of examples, so what questions do you guys have so far? This is the introduction. Tomorrow we'll actually be writing equations explicitly and recursively. Those formulas that you learn will be given to you on your test. So you'll learn some formulas. They don't have to be memorized. They'll be given to you on your test. They're also given to you on the actual EOC as well. All right, so do we have any questions before we do the last examples here? Okay. Write the next 3 terms of the sequence, determine the common difference, then we will graph it. So, First of all, this is they give you the output. So this is your output here. So you need to understand that your input, or n, means that this is 1, 2, 3, 4. Remember, you always start at 1 in an arithmetic sequence. Okay, so we have to list out the next 3 terms. So we need to figure out what our common difference is. What is my common difference, Alex, in this problem? What is happening each time? You are subtracting 1/4 each time, aren't you? So our common difference is -1/4. So what would be my next 3 terms then, Sarah?
3, 2, 3, 4.
So she just kept subtracting 1/4, right? Is that all you did, Sarah? Good. So from there, we can label our graph. We have 1, 2, 3, 4, 5, 6, 7. So I think you can skip every other one. You're wrong. Nope. Okay. So those are our n values at the bottom. And then we have to figure out the scaling to get through 4. So let's see here. So if I do 1/4, half, 3/4, 1. I don't know if this is going to work. 1, 2, 3, 2. 1, 2, 3. So is that going to get everything? Will that scaling work? I will not get to 4, will I? So I might have to count by halves then. So this will be a half 1, 1 1/2, 2, 2 1/2, 3, 3 1/2, 4. So still working on that scaling that we talked about with the line of best fit. And then we can plot our points. Do you connect your points in arithmetic sequences? No. So 1, 4. 2, 3/4. 3, 3 1/2. You don't have to do the back. Did you do the back?
Yeah.
Sorry. Did you finish this one? Okay. Sorry. Should have said that. And then 4 is 3 1/4. Put it in the wrong spot. Then I got 3 what is that? 5 3. 6 2 3/4, and 2 1/2. So that's what our arithmetic sequence would look like. I'm sorry, Carly. Okay, questions on that one? So again, they give you your output, which means your input, you always start at 1. So that means it's 1, 2, 3, 4. So we need to do the next 3 using our common difference. So Alex, what is my common difference? You subtract 2 every time. So my common difference is -2. So Vivian, what are my next 3 then? Very good. Again, we do not connect the points. So now we have to do our graph. So notice we put the axes on these graphs for you. We wanted to make sure it wasn't super difficult for you guys. So I'm going to label again every other one up here. So you're in quadrant 4. And then I have to get to negative 14. So we can just count by ones if we really wanted to. We just don't have to get the negative 14 on there. Not a huge deal. So this would be negative 2. I'm just skipping lines just so I don't have to get it all bunched in there. But I am counting by 1. And then you plot your points. Do we connect our points? No. And then you have your problem. So we said the next 3 terms, we stated the common difference, and we plotted our points.